Here's another decision tree question. Consider the following game. Company X is considering whether or not to enter a new market. There is one firm already in the market, Company Y. The timing of the game is as follows. X decides whether to enter or not. So let's start off with a decision node for X. It has to choose whether to enter or not to enter. So far so good. If X chooses not to enter, the game ends and Company X gets nothing and Company Y gets 20. So at the end of this game, X gets nothing, Y gets 20. If X chooses to enter, on the other hand, Y needs to choose whether to punish or accommodate. So at this point we get another decision node. This is a decision node for Y. It has to decide whether to punish or to accommodate the invader. If Y chooses to punish, then the payoffs are going to be -5 for X and 5 for Y. So at this point, the game would end with -5 for X and 5 for Y. If, on the other hand, Y chooses to accommodate X, then the payoffs would be 7 and 8 respectively. So 7 for X and 8 for Y. What is or are the Nash equilibrium or equilibria for this game? Alright, let's work through the game. Now, let's start at the end of the decision tree from the perspective of Y. So let's say X has chosen to enter. For Y, it's going to be a question of whether to punish and get 5 or to accept or accommodate and get 8. 8 is better than 5, so it would choose that outcome. And so 7 would be the outcome for X if it went down this route. It'll end up here. So X thinks to itself, if I enter, I'm going to end up with 7. On the other hand, if I don't enter, I'll end up with nothing. Which would I prefer? I prefer 7 to nothing, so we end up here. This equilibrium. Is this a Nash equilibrium? Yes, it is, because if, say, X were to move away from this strategy, it would end up in a worse situation. That is, if instead of choosing to enter, it didn't, it would end up with 0. That's worse. What about for Y, on the other hand? For Y, it doesn't get to choose whether X stays out of the market. So for here, Y, it's operative from here on. From the perspective of Y, would it prefer to stay with accommodate, or is there an incentive to shift away from accommodate? Well, no, there isn't, because it would get 5 instead of 8. So it has no incentive to move away from this outcome either. That's one way to think about whether it's a Nash equilibrium or not. Is there any incentive to move away from that equilibrium? But the question does raise this issue of equilibria. Is there another outcome here somewhere where if they did end up there, there's no incentive to move away from it? We know this is one of them, but is this one or this one a Nash equilibria? Well, no, because if they did end up here, X has an incentive to move away from this outcome. It has an incentive to go to enter rather than stay out of the market. So this can't be a Nash equilibrium. What about up here? Well, it's not an incentive. There's no incentive for Y to stay here. It's better for Y to move to accept. So this would not be a Nash equilibrium either. There's no incentive to stay here either. Right? So we know that there's actually only one Nash equilibrium.